we'll discuss SR latch circuit. As the name suggests, S refers to set and R refers to reset. So the circuit we will draw with the help of NOR gate. Let's draw a NOR gate here. So it's a basically 2-input NOR gate. With the help of 2 NOR gate, we will develop SR latch. So the circuit will be like this. So here, as we can see, the inputs are S and R. These are our set pin and reset pin, and the outputs are Q and Q bar here. So when we will make S equals to 1, it will make output Q equals to 1. And when we will make this reset pin R equals to 1, it is a reset pin, so our output Q will become 0. So this is all about set and reset in digital electronics. Now we will see the function of this SR latch. Basically, as I told you, the SR latch will work like a memory element. Memory means whenever we will remove the input, it will retain the previous output. So that is our memory. Since we have used a NOR gate, let me draw the truth table of NOR gate. This is a NOR gate. The inputs are A and B, and here the output equals to Y. So the truth table will be like this. Since the inputs are, there are 2 inputs, so a combination of inputs will be like this: 0, 0, 0, 1, 1, 0, and 1, 1. So the formula is 2 to the power n. The n is number of inputs, so the number of possible combinations are 4. So in a NOR gate, whenever any of the input becomes 1, it will produce output equals to 0. Only when both the inputs are 0, it will make the output equals to 1. This is the conclusion. If any of the input equals to 1, it will make the output equals to 0. This is very, very important. Now, we'll implement here in this SR latch. So in case 1, let S is equal to 0 and R equals to 1. Here S equals to 0 and R equals to 1. If you refer to this truth table of NOR gate, if any of the input equals to 1, it will produce the output equals to 0. So since here the input R equals to 1 given to this NOR gate, so it will produce output equals to 0. Now here you can see the input of one gate is driven by the output of another one gate. So here the output of this NOR gate is driving the input of the first NOR gate. Okay. So here both the inputs are now 0. So when both the inputs are 0, it will make the output equals to 1. So here I can conclude Q is equal to 1 and QR equals to 0. So when our inputs are S is equal to 0 and R is equal to 1, it will make the output Q is equal to 1 and QR equals to 0. Now we will see how it will work like a memory. So as I told you, memory is nothing but whenever we are removing the input, it will retain the same output. So here let me remove the input. Now I can say the inputs are 0 and 0. Both the inputs are 0. And my previous output are 1 and 0. This is the previous output. So input to this NOR gate is equal to 1 and 0, and here it is 0 and 0. Okay. So since one of the input equals to 1, so I can write here output equals to 0. So the new output is 0, which is matching with the previous output. Okay. So the new output when S is equal to 0 and R equals to 0, I can write like this. This is Q and Q bar. Here Q bar equals to 0. Okay. Now you can see to the first NOR gate, both the inputs are 0. So obviously it will produce output equals to 1. So the new output equal to 1, which is matching with my previous value. So here Q equals to 1 and Q bar equals to 0. So I can say that when I am removing both the input, it is maintaining the same output. You can match both the outputs are same. So it is working like a memory, I can say. Okay. So this SR latch is working like a memory. Even if I remove the input, it retains the previous value. Now we'll go to the second case, case 2. Okay. We'll change the input value and we will see the output values. This is our Q bar. So in case 1, we taken S is equal to 0, R equals to 1. So we will change the value S equals to 1 and R equals to 0. This is our S and R. S equals to 1 and R equals to 0. So similar table we will follow. If any of the input equals to 1, it will produce output equals to 0. This tabulation. Okay. Now input to this NOR gate equals to 0 and 0. So it will produce output equals to 1. So when S is equal to 1 and R equals to 0, we are getting output Q is equal to 0 and Q bar equals to 1. Okay. Now let me remove the input S equals to 1 and R equals to 0. Since I removed the input, so I can say the inputs are 0 only. S is equal to 0 and R equals to 0. And our previous output is equal to 0 and here equals to 1. Q equals to 0 and Q bar equals to 1. This is the previous value. Now S equals to 0 and R equals to 0. Both the inputs are 0. So here the input to the first NOR gate equals to, it is 0 and here it is 1. So obviously the output will be equals to 0. This is the new output. Okay. This is the new output and this is the previous output. Since one of the input equals to 1, output will be equal to 0. Now this output of the first NOR gate is fed to the input of the second NOR gate, which is equal to 0. So both the inputs are equals to 0. So the output will be equals to 1. So the new output equal to 1. So here I can write Q equals to 0 and Q bar equals to 1. So clearly it is matching both the previous output and the new output is matching even if I removed the input. Okay. So I can say the circuit is working like a memory. This is nothing but our digital memory. Now we will go to the case 3. Here I will make S equals to 1 and R equals to 1. Okay, let's change the input values. Here S equals to 1 and R equals to 1. As I told you from this tabulation, if any of the input equals to 1, it will produce output equals to 0. So since S is equal to 1, so this NOR gate will produce output equals to 0. Let me write the new output, which is S equals to, this is Q is equal to 0. Since any of the input equals to 0, we no need to think about this input. It may be 0 or it may be 1. Any of the input equals to 1 means it will definitely produce output equals to 0 irrespective of the other input. Okay. So here S equals to 1, here output Q we are getting 0. Similar case, here R equals to 1, so obviously this Q bar value will also be equals to 0. Q bar value will be also equals to 0. So I can write Q equals to 0 and Q bar equals to 0, which is very, very disturbing. According to our truth table, it is not satisfying the condition. So this condition S is equal to 1 and R equals to 1 is never used, because here the value of Q, whatever value we will get, here we will get the complement Q bar. But here in this case it is not like that. Here Q equals to 0 and Q bar is also equals to 0, which is contradict of our principle. So this case 3 is not used. Not used. This is one demerit of this SR latch. Now, this is not only one problem, there is another one problem also. As in the previous cases, we have seen it is working like a memory. So that we will verify here also, and we will check whether it is working like a memory or not. Now, let me remove both the input. I mean S equals to 1, R equals to 1, it was the previous input. Now, I have removed the input. Now, S equals to 0, R is also equals to 0. And my previous outputs were here equals to 0, here Q equals to 0, here it was Q bar also equals to 0. Now, let me verify whether it is maintaining these two value after removing the input or not. Now, I will start from here. This input is fed to this output of first NOR gate is fed to the input of the second NOR gate. Now, both the inputs are 0, so it must produce output equals to 1. It must produce output equals to 1. This one, this combination. Okay. Now, this output is fed to the first NOR gate. So, inputs are 0 and 1. So, according to our principle, according to our tabulation, if any of the input equals to 1, it should produce output equals to 0. Q should be 0. It's okay. Now, S is equal to 0 and R equals to 0. I removed the input. Now, the value I am getting is Q is equal to 0 and Q bar equals to 1. It's okay. Now, initially I started from here, from Q I started. Let me start from Q bar. From here if I will start, then what output I am getting, that I will match. Now, let me start from Q bar. The value of Q bar was, so here when S is equal to 0, R is equal to 0, the value of Q is equal to 0 and Q bar equals to also 0. Now, if same thing I will apply here, here both the inputs are 0 and 0. Okay. So, output must be 1, here Q must be 1. Okay. Now, the same output is fed here. So, here any one of the input is equal to 1 means it should be 0 output. So, here in this case when we removed the inputs, that is equals to S equal to 0 and R equals to 0, we are getting the contradict output. If I am starting from Q, I am getting Q equals to 0 and Q bar equals to 1. If I am starting from Q bar, I am getting Q equals to 1 and Q bar equals to 0. So, this due to this case 3, the entire system failed. So, in this case S equals to 1 and R equals to 1 is never used. So, this is a major demerit of SR flip-flop. Another one thing is that before using the circuit, we need to know what circuit is used inside the flip-flop. Either it is NOR gate or NAND gate. Accordingly, the output will change. In our next session, we will discuss the SR flip-flop which implements NAND gate. Thank you.